Welcome to spring semester. Welcome to Calculus 2. Today, we just want to do a quick reminder of what Calc 2 is going to be all about. And for that, we're going to look and remind ourselves what Calc 1 was all about as well. If you would recall, there are two big questions that we look at in calculus. So there are two big questions that we care about in calculus. If we're thinking about a function, and I'm going to draw the same function that I always draw. If we consider a function, there are two big questions that we ask in calculus. First, given a particular point on the function, so at the point C, f of C, what is the slope of the line tangent to the function at that point? So one of the big questions is, what is the slope of the tangent line at that point? And this was a question that we spent time looking at in differential calculus. So the slope of the tangent line is the derivative of the function evaluated at the point. That was the answer. That was the mystery that we solved in the first semester of calculus. And at the end of the first semester of calculus, we start talking about the other big question. So if we have a function the big question for integral calculus there might be a delivery outside, so my dog is warning us. He's just doing his job. He keeps the mailman from coming in and murdering us every single day. He doesn't get enough credit for it. He doesn't think. The other big question in calculus is, what is the area under a curve and above an interval on the x-axis? So the area under the curve and above the interval. And that, we discovered, was a question for the definite integral. So these are the two big questions for calculus. What's the slope of the tangent line? What's the area under a curve and above an interval on the x-axis? Then there's all the extra stuff that goes along with it. How do we find those things? And what can we use these things for? Why would we want to find those things? On top of this, the other big question that runs along with these two questions is we want to think of calculus as the study of infinity. So the bigger picture is that in calculus, we're learning about infinity. Moreover, calculus is the study of infinity. So moreover, we want to think of calculus as the study of infinity. And we want to remember how infinity shows up in each of these calculations. So we want to think about how infinity shows up in each of our big questions. That's what we want to look at. In Calc 2, we also get another big aspect of infinity when we start looking about infinite sequences and infinite series, and then infinite polynomials. So what ties calculus all together is really the idea that we're starting to look at infinity, and we're starting to think what we mean when we say infinity. What is that? How does that concept affect what we want to calculate? What do we mean when we talk about the infinitely large and the infinitely small? Any questions? Great. Let's pause the video here and talk about next steps.